Ciao, grazie. Thank you very much to Søren and Wandy Pedersen from Frese. The title is Revolutionizing Fuel Efficiency in Marine Operation. The floor is yours. Thank you.
Thank you. Let's see if I can get this to work. A little bit taller. There we go. So it's going to be in English. My Italian is a little bit rusty, so do apologize for that. So the company I work for, very briefly, is a Danish company founded just towards the end of the Second World War. We always been involved in the maritime industry, early days from having a foundry, but later on as more of an energy efficient valve supplier. So we supply different type of valves. And then more recently, the last 4 years, on the back of COVID-19, we have developed entire energy saving flow management systems, and that's what I'm here to talk about. So the agenda is some of the early presentations. It's about saving energy, energy efficiency, energy saving device technology, which is the terminology that we tend to use in the industry. So most of you may be aware that all the vessels, certainly if they're older than a few years, around the world has been designed to run at 100% design conditions, which means that whether your seawater pumps, your freshwater pumps, everything, engine room fans are actually, to some extent, designed to run at 100% load all the time. They also tend to run at 100% load. Only if you switch off the main engine, you can actually switch off some of your pumps. And what that means is that the reality, so to your right, it's a Maersk vessel. The reality, the actual operational pattern is very different from how vessels are actually designed. And they rarely operate anywhere near, 100%. And that basically means that you have, for instance, pumps that are wasting an awful lot of energy because they are overcooling, they have overflow, they're just running at a state that is, totally unnecessary. And particularly when you talk pumps, so, I'm not going to go into the math here, but the pump affinity lower is if you can reduce the flow in cooling systems, whether it's HVAC or in the engine room where you have a lot of cooling consumers, if you can reduce it with 50%, which you can, then you're actually only consuming 12.5% pump energy. So there are significant opportunities to reduce flow in actual operations when you can control it. And the control thing is the key, and that's where we have developed over 4 years and got a global patent on how can you actually control that on a vessel. Not going to go into a lot of details here, but some of our valves are pressure-independent control valves. It's technology, so this is just one of the components of our system, but this is the key enabler. This is technology that's been used on land for the last 20 years. Even in Italy, most of your new commercial buildings will apply pressure-independent control valve technology because it's it balances system. It's the most energy-efficient way to control hydronic systems. So the fuel-safe system that we talk about and what we offer is you can address your seawater system, your seawater pumps. That's fairly straightforward. You can apply variable frequency drives. You can put that on your pump. You can then look into your low temperature freshwater system. That's where it becomes a little bit more complicated because you typically have 30 to 40 cooling consumers. Main engine, auxiliary engine, loop coolers, scavenger air coolers, etc. You can address your engine room fans, who are also wasting a lot of energy. Your high temperature fresh water, your entire boiler. The problem you have there is that you have some valves that are leaking, so your water is running back and you have to reheat it with your preheater, again using unnecessary energy. So what we've looked at is look at all these processes and actually try to develop a system that can address all of it. So we've done that really by going in, looking at the individual cooling consumers. We're putting in our valve technology. We're squeezing so every cooling consumer only gets exactly what they need in any given load condition. And then the minute it detects, so we have a differential pressure sensor that kind of detects if the pressure is now too high, then we can throttle down the pumps, we can tell the VFD you can slow down the pumps, and it all happens real time. These are some of the customers. We've done it, so I'm not talking about something that is a pilot. We've installed it over the last 3 years. We've done close to 100 new builds. We have done more than 25 retrofits now. And I'll give you some examples. So what are the actual savings by applying this technology, and what is the return on investment? Because that's always the question I get from ship owners. So here's an example. We just commissioned this a couple of months ago, an LNG carrier. So our system in total saves over 720 metric ton, return on investment under a year, and the total fuel savings of their total annual fuel consumption was 4.3% by just addressing the entire engine room and all the wasted energy in pumps, basically. And it's mind-blowing. For most vessels, 50% of the energy generated is consumed on board, and 50% is actually only propulsion. And we tend to say, that the best energy is the one you don't use. Here's another one. We've done a number of vessels for DFDS. You may know them. They also have a ship out of an operation out of Trieste. This was a minor. We only addressed the low temperature freshwater system. We did some boiler optimization. But again, under 3 years, 2.5 years, 2.8% of their total consumption, annual consumption. On container vessels, it gets crazy because they have so much waiting time. So while they're waiting to get into harbors, all their engines are running at 100% load. So enormous amount of wasted energy. Applying our system, over 1,000 metric ton annual saving, just 4 months return on investment, and total fuel savings of 7.4. And here's another example. So we've done all types of vessels. The only one we haven't done yet is a cruise ship, but I'm hoping to land an order in a few months' time so we can get that in as well. So what we do is we tell ship owners and ship management companies that we will offer you a free business case. All we need a bit of data. If you provide that to us, then we will give you a free of charge business case. So that's how we operate. And then if customers are interested, then we'll go on board and do a survey to verify that what we actually see on the P&ID drawings relates to reality. Because as you know, some of the older vessels has been through a lot of retrofits. They have ballast water treatment, scrubbers, all sorts of things applied. And sometimes the original drawings doesn't really tie in with what you actually see once you get on the vessel. So that's really what it is. It's all about, saving fuel. And obviously, if you can save fuel, you can also reduce your CO2 footprint. And this is not magic. It's common sense. I mean, energy efficiency is one of the lowest hanging fruit. Yes, we need green fuels, we need power to X, we need ammonia, we need methanol, we need carbon capture, we need all of that. But just bear in mind that actually just doing a few energy efficiency things is the fastest way to get, your fuel consumption down. And that's something that technology is there today. We've installed over 100 new vessels, 25 retrofit vessels. So this is not something that is in pilot. It's working. It's out there. It's happening. So if I could ask the organizers to run a short video.
Climate change is one of the greatest challenges of our time. The global shipping industry alone accounts for nearly 3% of the annual global CO2 emission. That makes it a significant contributor to global warming. To combat this, the International Maritime Organization and the European Union have set ambitious targets to reduce emissions and the carbon intensity of ocean-going transport. As a result, the decarbonization agenda is gaining momentum, and the need to improve ship energy efficiency has become an important factor. The CII framework and rating system are a consequence of this, and the required improvement targets are continuously increasing. Even though the task is challenging, there are well-proven technologies that can help you. To reduce carbon emissions and improve fuel efficiency, vessel owners and operators have several options, including operations optimization, switching to low-carbon fuels, modernization of vessels with energy-saving technology. On a typical bulk carrier vessel, energy use is divided almost equally between propulsion and onboard energy consumption. While a ship is typically designed for 100% design load, they rarely operate at full capacity. This presents a huge opportunity for more efficient operation. With Frese's proven fuel-save technology, you get safe and energy-efficient operation in all operating modes with an integrated flow management solution for engine room cooling systems. Frese's fuel-save solution enables you to run your engine room cooling water system using the lowest pump energy at all times. This is made possible by dynamic valves positioned at individual cooling water consumers. Strategically located differential pressure sensors detect when the pump speed can be lowered. They send a real-time signal to the variable frequency drives, allowing the pumps to run at the optimum set point. Frese's low-leakage three-way control valve ensures accurate temperature control in the system. All parts of the system integrate seamlessly and are managed by a touchscreen control panel. The result and impact of an installed Frese fuel-save system are substantial. For example, you can obtain total fuel savings of 120 metric tons per year on a handy-size bulk carrier, and you can reduce CII by 9%, more than quadrupling the yearly target of 2%. Whether in a new build or retrofit scenario, the result is fuel savings of 5 to 10% annually. Want to learn more about the Frese fuel-save system? Get in contact with us and learn how it works. You can get a free-of-charge detailed business case for one of your vessels. Just reach out to our team and let us help you reduce CO2 emissions so you can optimize to economize.
Thank you.
Thank you.